Hi everyone. We're ready almost for our Licrox live chat number 4. Let me just invite our interviewed person today, who is Ana Loiudice. She should be about to join. There she is. Okay, here she is.
Oops. Let's see.
There you
Okay.
are. Okay, great. How are you, Ana?
Good, good.
Good?
How are you?
Good. I'm great out here in Tarragona. It's super sunny and nice,
Oh,
so I'm
nice.
enjoying some fresh air. How about Switzerland?
Yes, today is a bit colder than yesterday, but still sunny.
Okay.
But yeah,
If it's
I still
sunny,
I
then it's not
like.
bad for Switzerland. Okay, so let me just introduce you to our audience briefly. So today we're going to talk to Dr. Ana Ludice. I don't know how to pronounce it. Lodice.
Me too. Nice. Loiudice.
Loiudice. Okay, so Dr. Ana Loiudice, who is originally from Italy but is now living in Switzerland, in Sion, because she's working as a postdoctoral researcher in the Licrox project. And although she's working for the Technical University of Munich, she's actually set in the EPFL in their Sion headquarters, in their Sion site. So, Anna, that was my introduction, very brief, as I said. Can you please tell us a bit about yourself, introduce yourself, where you come from, etc., where have you worked?
Yes, sure.
Great.
So, hello everyone. I'm Anna Loiudice. I'm Italian. So I come from Italy. So I was born in south of Italy. So like my hometown is actually a small town that is called Altamura. That is in Puglia. Like a very nice town. If you have the chance to visit, it's nice.
We will.
And in Puglia, I studied. So I did all my studies there. So I did my university, both bachelor and master, in the University of Bari. That is very close to my hometown. And then I went to the University of Lecce, specifically in the Italian Institute of Technology, to do my PhD.
Okay. That is in the north of Italy, isn't it?
No, no. So it's
Ah,
the main center is in Genova in the
okay.
north, but then there are different satellites, and there is also
Ah,
one in Puglia in Lecce.
okay.
So,
Sorry, it just got confused.
so it's quite big. It's a bit everywhere in Italy, but yeah, the main one is in Genova.
Okay.
Yeah, and then so during my studies, I study material science, both bachelor and master, and then my PhD was more focused on device fabrication and synthesis on new material. Yes.
Okay. And have you always worked, I mean, originally from Italy, but now you're working in Switzerland. Has your career as a scientist brought you somewhere else?
Yes, sure. Yes, so after my PhD in Italy, I went for 1 year and a half as a postdoc in Berkeley, that is close to San Francisco in California. And then after that, I joined EPFL as a postdoc where I am now, actually in Sion. But then in between now and when I started here, I also was in Munich for a few months only. But yes, right now I'm a postdoc in Technical University of Munich, but I'm a visitor in EPFL Sion.
Exactly. Okay. Okay. So now that we know you a bit better, can you tell us what attracted you about science? Why did you decide to become a scientist?
So actually, like already when during my high school, I was really passionate about math. So then for my studies, I was thinking, how can I use my knowledge in math, my passion for math? So instead of doing math, like pure math, I wanted to do something more that I wanted to use math for something that could be useful for the real world. And for this reason, I decided to do material science as a university degree. And yeah, so basically my main driving force was the love for math. mathematics. And then while during the university, then I really see how that passion for math could be useful, because then I could apply it to chemistry, to physics, and then until really learn more about devices and technology, and then still I could use my background in math.
Okay.
Yes, so the money.
So applying something abstract to tangible solutions, no, would be. Sorry, excuse me. Okay. And now that you're working in material science, what is the thing you enjoy the most of this kind of work?
So, so the thing that I really like of material science is more material science in nanomaterials, applied to nanomaterials. It's also actually what also I really like during my university was all the courses related to nanomaterials. And so right now also my research is mostly focused on nanomaterials, and I really love to be in the lab and synthesizing new materials that are nano, and also see how can I apply them to devices that are mostly with the energy application. Yes. So I really love to be in the lab, I have to say.
Well, then you chose the right path then.
Yes.
Okay. And in the future, how do you see yourself, or where do you see yourself working in 5 years? Like, what would you like to be doing?
Yes, I hope that in 5 years I'm still in academia, surrounded by many colleagues with also different expertise, both chemistry, physics, engineer, and still keep improving my knowledge in science. So yeah, this is what I really would like to do in 5 years, basically.
Okay, but
Maybe still here in Switzerland.
still in Switzerland, huh? And but do you think you would change? I mean, would you be willing to change fields somehow? Because now you're,
Yeah.
working in CO2 reduction. I mean,
Yeah, so the most important things for me is, let's say, material science. So as far I can develop new material, for me, it's not really important that is on energy-related projects, but could also be in biology. I would also be happy actually to learn more about also other fields. So the most important is that I can focus on new material development. And yeah, no matter. Yeah, yeah. I like also the energy related aspect, but the most important for me, I really like more basic science, and how I can develop new material, how by modifying this material I can influence efficiency or properties and so on.
oh, okay. Um, have you ever, I don't know, found a material that, or worked with something that you were expecting one use or one application, and then it surprised you and it really went the other way somehow?
Uh, no, because in the end, all my projects they were always energy related.
Okay.
So actually, no.
All right, fair
No.
enough, fair enough. It was already well, planned and focused.
So yeah, exactly. It was already well planned. So there was no chance to deviate.
Exactly. Okay. Okay, so I would like to talk a bit about the Licrox project itself. Um, can you tell us a bit how you perceive the project, and if you think like the outcomes will be relevant for the field and society in general?
Yeah, sure. So what I think about Licrox is that I really like Licrox project because it's the first time I am involved in a project that is that involves many patterns, and each of them has a different expertise, and I really like it because it's very collaborative. I can during the meetings and yeah, all the chat we have, I can really learn a lot from molecular chemistry or device itself, or also modeling. So I really like it, how the project is itself. And also, I think because it's so collaborative, I think if we are able really to build to reach the goal that is to build this device that can at the same time absorb the light and then transform this energy in useful chemicals, I think will be very relevant for society. Yeah, because it will help to solve the energy problem that we are facing also right now.
Yeah.
And so I think the impact will be huge for society. But then, yeah, in the meantime, I really like it because it's basic science related yet still with a big goal in technology. And yeah, I like it that I can learn a lot from other people.
Yeah, that's true. And because of course it's still basic science, no? Creating this device. Um, from a materials point of view, do you think it will be like a leap forward for this kind of for this area of solar fuels?
I think so because yeah, we are working with the kind of new material that are like cheap and air friendly. So whatever we learn from the basic science point of view will be usable from for other type of devices, for example, in the future. So even if we don't reach the final goal, I think all the knowledge we will build up will be useful also for solar cell or other type of application. So yeah.
Okay, great. Okay, and can you tell us a bit about your role? What are you doing in the Licrox project?
Yeah, so I'm a postdoc in the project. And then also, if you have seen on the webpage, the device is kind of big and there are different parts. And I'm working on the cathode side, so on the right part, that is to develop photocathodes that are able to absorb the light and then transform the electrons that we generate, the energy that we generate to transform CO2 that is carbon dioxide in the useful products that could be ethylene, methane, or also liquid products like ethanol.
Okay.
So,
Oh, go ahead.
no, yeah. So I'm a postdoc working on developing a new photocathodes, basically.
Okay. Okay. No, because I was going to ask you, maybe you could tell a bit about the device itself for people who are not scientists. Could you give just a bit?
Yeah. Yes. So the device is it will made of it will is like is made of two compartments. In one compartment, there is a material that is called photoanodes that is able to absorb the light, but in a specific range of the solar, so like low energy. And then the energy that will be absorbed will be transformed in electrons, in current. And this current will be transferred to water and will from water will generate oxygen. And from the other side instead, so the same current then will be transferred to the other side, and the other side is called photocathodes. And in this other part of the compartment, there will be again water, but then full of CO2 that is also present in the atmosphere, and we want to get rid of it. So this CO2 will be then will take the electrons and will generate other products that are ethylene or, as I mentioned before, methanol. And then all these products will be collected and utilized. But then a good advantage of this device is that then you can collect these products and you can utilize them whenever you want. Instead, like for example, if you use solar cell, the solar cell they need to be always with the sun in order to be used. And so so what we do is to generate energy that can be used whenever we want.
Exactly.
With this type of device. So also during the night or when there is no sun.
See, because you will have a fuel that is liquid and that you can, or gas or whatever.
Yeah.
But you transform that energy into a chemical storage somehow, which is what we have now with gas, but
yeah,
that's why we like it. Okay. And working on your side of the photocathode, sorry, have you encountered some challenges that unexpected, of course? Can you tell us a bit about how you dealt with that?
Yeah. So do you mean
See, I mean,
to discuss about
sorry? Oh, you broke
to
up.
discuss about the work that I'm doing
see, like, if you were expecting some outcome that didn't you didn't get in the end, and if how it surprised you, or like how did you deal with that unexpected
But
results?
okay, always related to so for example, okay, what I started to do. So the first step was to synthesize these photocathodes, to develop a method to synthesize these photocathodes. And the specific material that I had to synthesize, it exists in multiple structures.
Mm-hmm.
And so like, that are called, like maybe not easy to understand, but they are called this spinal structure or the lipocyte, where basically the atoms are positioned in the different ways.
Mm-hmm.
And the only one type of structure is useful for our application.
Okay.
So I had to find a way to
So,
direct the synthesis in one direction. And so yeah, so then so at the beginning I was challenging because I could not find the right procedure. But then yeah, I found that depending from the initial precursor that I use for the synthesis,
mm-hmm.
the initial ingredients that I put for the synthesis, I can control the final products.
Okay, great.
So, but yeah, it was challenging in the beginning, so that you almost say, "I will never work, it will never work,"
But in
but
the
then
end,
finally you find something that actually it works.
yeah, great. I'm happy it did. Okay, and okay, I saw well on the website or on the Licrox website. There's a paper that you published recently. Can you tell us a bit
Yeah.
about it? What is it about?
Yeah. So it's actually about this that I just mentioned. So I had to develop this method to synthesize this copper iron oxide that is the photocathode that we want to use. And I wanted this material exactly in a specific structure.
Mm-hmm.
So what I found is that we develop a new method to synthesize this material where that it consists in mixing nanoparticles in solution and then heating at high temperature to melt them, to fuse them, and to make them to react together. And so then what I found is that by choosing carefully the structure of the initial material, that were iron oxide and copper, I can direct the final structure of the material. So right now I'm testing them and see if they are able to do the job, if they can absorb the light and then transfer in an efficient way the electrons to the CO2 to do to produce multiple products. So the first part so that was then published in this work was on the synthesis of this material.
Okay. And we'll be expecting a second part then?
I hope so. Yeah,
Okay.
I hope so.
Looking
So
forward to
far,
that.
yeah. I don't want to spoil anything.
No, please don't share it yet. It's confidential. Great. Okay. So, okay, moving on now back to your more personal side, no? As we were saying earlier, as a researcher, you lived and worked abroad, like in Italy, in Switzerland, or in Germany, and in the States. Um, can you tell us a bit about the difference you've experienced working in these different countries?
Yeah, sure. Yeah, so actually the one nice aspect of being a researcher is that you are kind of forced to go around the world. So and then you find that it's really nice because you can learn many things from all the different parts of the world. And but then so like in the US, I was in California, and then specifically very close to San Francisco. And okay, I have to say that it's not so much different. It's really like it's most European part of US, but yet you can find some differences. But I think more in the small things. For example, I don't know, like when I went the first time in a supermarket in the US in San Francisco, I was impressed because
Yeah.
there was I just had to buy a yogurt, I don't know, just a little yogurt, but then you have this fridge huge full of many different type of yogurt that they are sell in these big cans.
That's true.
Everything was huge. And then also that it was shocking for me that I can wake up in the night and go to a supermarket because they are open 24 hours. 24 hours. That is crazy. Instead, when I came when I came here in Switzerland, then it was the contrary. So
Yeah, it's
six after
at
after 6:30.
5:30. Yeah, there's nothing open.
So you really need to plan in advance, otherwise you can end up
That is true.
not
That
good.
happened to me too.
But then, yeah, here I feel more safe, let's say. It's like, yeah, you can work easily in the
See,
night, no problem. So there are these differences.
yeah, there's pros and cons everywhere.
Yeah, yes, exactly. But yeah, I really like also, yeah, US, you can see, experience different, I don't know, San Francisco is super nice. You have all these hills, and they are also impressive. And now, okay, in the mountains, I really like, yeah, there are a lot of mountains. Or yeah, in Italy, I was more surrounded by sea. So I
Oh,
could
yeah.
really, I could really enjoy different. During the last 10 years, I really lived in different parts, in different atmospheres.
Taking the best of everywhere. Huh?
Yeah, yeah.
Yeah, that's the way. That's the way to do it. Okay, so um, I guess you like enjoy doing things that you like outside the lab. Can you tell us a bit about what are your hobbies, or what do you do? What have you done in the different places that you've lived? For instance, have you changed hobbies when you change place?
So yeah, when I was in US, yeah, so it's a big city. So I was living very close to San Francisco. That is a big city. So what I like to do there mostly, well, I think the most things that I like to do there was to take a bike, and then because there are all these bike roads everywhere in San Francisco, you can really
Oh,
bike everywhere,
with those
and also.
heels.
Yeah, but even with the hills, it's nice because you can put your bike on a bus
Ah, okay.
and then go up. But then the problem is when you go down, to be really, really careful.
See.
And then also to visit the city around, or also in the US, you can just take a car and drive along the coast. And it's really beautiful. You go from desert to big city in a
That is
few
true.
kilometers. It was amazing. Instead, here in Switzerland, I really like to go do hikes and then ski, snowboard is what I do. I really love to snowboard in the mountains. So and I look forward each winter to start the snowboarding season.
Season, I bet. Do you have like are they the ski resorts or snowboarding slopes? Are they far away from Sion? Is it a long ride?
Uh, Super close, super close. Like in 15 minutes, you can be on the slopes.
Oh, wow. Wow, that's impressive. Okay, I didn't expect that. And what about the summer? What do you do in Switzerland during the summer?
It's the same, just instead of skiing, you walk. You walk, and there are some beautiful glaciers, so you can really go close to them. It's really impressive.
No.
It's very impressive, and also a bit sad from another side because every year you can see the ice melting,
Have you
and
seen it? Like in the how long have you been in Sion now?
and now it's 6 years.
6 years. Okay, okay. And can
Yeah.
you tell from the when you first arrived until? See.
So, so actually, I take photo of the same part, and you can really see the difference after 2 years. So you can really see they are not anymore the same glacier.
Oh wow. Oh, that's so
Yeah,
sad.
yeah, it's very sad. Yeah, very emotional. And also there are these glacier where they go there, they write here in 2008 it was here, 2011 it was
Ah, I
here. They
see.
walk up and see where it was during the different. So
See.
it's very.
Yeah.
But then,
Wow.
yeah, that one is beautiful. There are still big glaciers, so you can still enjoy them. Uh,
Yeah.
So this is
Well,
what I do in summer. I do that, or I travel and I go away from Switzerland, and because India is in the center, so I can
yeah, it's
fly
very
away.
convenient and it's very well connected, no, to
Yeah, yeah,
Central Europe. That is true.
yeah, yeah. So
All right. Okay, we're almost there. Um, okay, my last question, personal, would be What would you recommend to do to someone who's visiting Sion or Switzerland for the first time?
Okay, first Sion is very nice and cute town. It's called the town of sun. Indeed, like compared to the rest of Switzerland, is most of the time is sunny. So actually, yeah, it's not a surprise that it's sun today. It's always so when everywhere is cloudy, here is sun.
Okay, good to
That's
know.
nice. And then there are two hills. When on one there is a castle that is nice to visit, and then there is also a church in front. So this is like a representative of Sion. And then because only 20 minutes you can go to Anzer, or you can go to Cramontana, that is really close. You can just go there, or it's really also surrounded by thermal bath. So you can, and after a nice hike, you can rest
go
in
relax.
a nice thermal bath.
Nice, good. Okay.
Yeah.
Sounds like a good plan, I have to say.
And then in the evening, you can eat fondue, like a cheese in a pan. They have this typical food
The
from Switzerland.
raclette, no?
That is different. That is like they cut a
Sí.
slide of cheese. Instead, there is also a pan, special pan,
Vale.
where you melt cheese and wine.
Okay.
Together, and then you can eat with some bread and potato.
Delicious. Sounds so good. All right, great. Okay, and just to close the interview, I would like to ask you, what would you tell someone who is starting now a career in science, in chemistry? What would you tell them?
I will tell them that to go for it only if you are really passionate, because science comes with a lot of frustration. And so and you can beat this frustration only if you are really passionate about what you are doing. Because I think I see science really like
A roller coaster.
a roller coaster. So it's like a moment of joy and a moment of frustration. They can be very close to each other.
Yeah, well, that's life.
And so only if you are really passionate, you will enjoy it.
That is true.
So yeah.
Okay, great. Well, thank you very much for talking to me, Anna. This was a great talk. I really had fun. Hope the people seeing us from their phones enjoyed too. And well, that's it for our Licrox lab chat number 4, I think it was. Okay, I don't know. Sorry. Hope you enjoyed it too, and we'll see the rest of our audience on our next lab chat. So
Thank you very much.
thank you,
Have a
everyone.
good rest of the day.
And you too. Bye.
Bye bye.